cases that defy that concept, like the Selenelian eclipse, where we see the opposite of what we should expect to see if the Earth was truly casting a shadow on the moon.
Hmm.
Here, I'll post a picture in the side, just a second. Can you see that in the side? Taha?
Okay. Yeah.
Yeah, okay. Can you read it? You don't have to read it out loud. I
Mm-hmm.
just wondered if you can. All right,
Yeah.
cool. And I included a little blurb about it that it's not that rare. A lot of people think it must be, but it really isn't that all that rare. Have any thoughts on that?
Um. I mean, kind of surprised, but I have to look it up again.
Yeah, please do. Please do.
Yeah. Well. Thank you for this amazing knowledge.
Yeah, sure. There's tons more information too. I mean, that one laser test that was posted is just one of hundreds, probably even thousands. Um, and I'll give you some links in the side chat. And these tests are very well documented, and you can apply all the scrutiny to them that you should. And um, I hope you watch them and come back with more questions. Okay, I just gave you a huge list, so this might be kind of overwhelming, but feel free to go through there and pick and choose anything that you find interesting. The John D laser tests are really good too, and he's extremely thorough. This is one of the people that was a globe earther and sought to disprove the flat earth and ended up becoming a flat earther in the process. So I really like his evidence because he came at it from the opposite view, which actually, I mean, most of us did as well. Most of us came into flat earth looking to disprove flat earth. And when we couldn't find any evidence for the globe earth, that's when we began to take it seriously and seek to prove it ourselves.
Mm. Okay.
And I actually have to go. So if anybody else wants to take over, that'd be great. And Taha, it was nice talking to you. Please come back anytime with any questions and challenges, and we welcome all of it.
Thank you. Thank you. I had fun talking
Thanks.
with
Have a good
you.
day. All right. Bye bye.
Okay. Bye.
I'm gonna put on, DJ's Debate with McToon. If anybody wants to stop it, feel free.
I'm reviewing here. So Ice Bones, I just want to say Ice Bones was being a bit rude, so I took away the wrench. Right? Like I said earlier, you can disagree with people about things, about how they live their life. You can. No problem disagreeing. It's how you treat people. So don't treat people poorly. Right?
A few moments later.
You are an
Why?
asshole, dickhead,
Well, I've been
because
nothing
you're
but nice.
you're pretending to be nothing but nice, but you,
Shade,
dickhead,
you were just
dickhead,
saying you were
dickhead,
just look.
quoting you,
I'll mute you,
dickhead,
dude.
quoting you,
I'll
dickhead, quoting you, dickhead. Oh, he is a liar. When you're standing at the ocean, you can only see a couple miles out.
yeah. What
To the
about it?
left of the boat, there's a buoy that's obstructed by the horizon. Uh-oh, that's not possible in flat Earth. Now, it is possible, in the right conditions, to have something blocked on a flat surface.
So, if we have those conditions, we can have bottom-up obstruction on a flat surface. Do you agree with that or not?
I can make a prediction. I have the balls to do that. I will stand up and I'll say, here is my prediction for that distance, for that observer height. Here is the range of what we should expect for the bottom up obstruction. The question I have to every flat earther, does any flat earther have the balls to say, here is the flat earth geometry, optics, physics that predicts the amount of bottom up obstruction given these input values? Does any flat earther have that? Do any have balls? I don't think any do.
Yeah. If I could jump in for a second, I don't mean to change the topic, but if we could maybe go back to the you wanted some flat earthers to present some observations that are credible for flat Earth.
Yes, that'd be good.
All right, I got one to present. Can you hear me properly? I gotta speak quietly because it's 5 a.m. here in Poland.
Yeah.
All right, so I'll be quick. I'll grab the observation and I'll just present it. I'll present it in the side chat so it doesn't get lost in the text chat. If that's okay.
Okay.
All right, just give me 1 second. All right, so this is done at Revere Beach I think it's near Boston somewhere. All right, so I'm going to post the first image. All right, so this was taken from 15-foot observer height. Okay, this is a
So wait, you're
Nikon
putting it in.
P1000. In the
Where are
side
you?
chat.
Oh, there it is. Okay. All right.
All right, cool. So we got 15-foot observer height. We've got a Nikon P1000 with that's been infrared converted. Okay, and we have a 15-foot observer height, like I said, and we have a ship track in the distance. Okay, we can see the distance markation on Google Earth, and then we can see the red line, right? That's where the geometric horizon distance would be. Globe.
Okay.
Now, all right. So now, right. Next up, we have the ship. All right. So this is the screenshot from the ship tracking. All right. Just a moment. Here it is. Okay. So we have the coordinates here. Scarlet Isabella, and if you have a look, the coordinates match up on the Google screenshot.
Okay.
Okay. All right. Next up, we have a buoy that's basically between the ship and the observer. Okay, and the time that the observation was taken was around 3 p.m. and we have a reading from the buoy of the water temperature and the air temperature at 3 p.m. So I'll just post the data from that in the side chat. 1 second. All right, so here we go. There's that. And the temperatures. 1 second. It's the next one. All right, so we have air temperature 45 degrees, and we have the water temperature 45.9. Pretty close, right? If anything, it would work against flat Earth, right? We could have a slight bit of upward refraction, maybe. Okay, so now.
Well, all right. How far up is the air temperature at the top of the buoy?
Yeah, so you
Or do you
can
know
see
where?
a picture of. Well, it's just it's reading the air temperature. Yeah, it's probably not too far up above. Yeah, I'm not sure how tall the buoy is. Could look up the height of the buoy, but
Okay.
yeah, it's the reading that would go onto the onto the weather report, that kind of thing for that particular area. Okay, so next up, all right, so here's just a picture of the clock. So a picture of the clock was taken at the location just to show you that the observation was done at the time that buoy reading was taken. Right, so the guy that did the observation, he specifically, like you did with your sunset, right? He waited to find a day that was going to have pretty much uniform water and air temperature, and he's using the infrared as well, which helps a bit. All right, cool. Okay, next up, just a picture of the camera setup. Sorry, I'm a bit unorganized with this, but in just a second. All right, here's the camera setup. All right, so now I'll grab this is just a GIF of the observation. There's a ton more footage than this, but this will be helpful just for the presentation. All right, so we got the post. All right, it's just uploading now. All right, so this is the observation through the infrared from that camera. And what we'll see is the ship that's 10.6 miles out. Okay, and you can see the whitewash on the bottom of the ship. The ship's 10.6 miles away. And we have the geometric horizon distance should be at about 4.6 miles. Now we've pretty much mitigated the refraction issue as much as possible here. If anything, the refraction works slightly against FE.
So if you're going to do any low elevation measurements over water, well, your first goal is to have water temperature and air temperature be the same if possible. All right, what was the the distance to the ship?
10.6 miles. Right, so it should be about 22 foot hidden, something like 2 stories, 2-story building, a bit more than that.
Yeah, I wouldn't.
Was the buoy also at 10 miles?
The buoy's in between the two. So if you scroll back up to the picture of the buoy, okay, with the data of the buoy, you can see the buoy just there. It's basically in between the ship. You can actually see it when he zooms in.
Who was the original source? Was this a YouTube video, or where'd you get
No. This was my friend. You guys probably know him, Indio.
Oh yeah, I know Indio.
Yeah. What's up, Jesse? Good to see you, man.
Good to see you.
All right. So yeah, I can post Indio's video of it. 1 second. So this is This is his video. It might have a bit more footage than I showed. If you contact India, he can show you a ton more footage of it and give you a bunch more details. But here's his video about it. All right, so with that, water to air temperature, like we really, I mean, to have this work on a globe, you would have to have a refraction coefficient of something like 0.8, right? Like a huge amount of extreme refraction. We don't have the conditions. We don't have the meteorological
I
conditions
get about
present.
I got about 0.3 as a necessary refractive condition for that.
All right, so I'll just pop in a screenshot from Walter Bisland's. A second.
According to Andrew Thomas Young, it takes about 0.13 degrees centigrade per vertical meter to have circulating rays. In other words, the ray of light matches Earth curve. So, and it wouldn't even need to be that much, since the observer was not at they were a few feet above. So it wouldn't.
Well, the observer's at 15 feet, right? And we have what would cause upward refraction. Okay, so it would work in reverse to that. So we're not going to get
But now,
light
why
bending.
did you put hidden zero?
Hidden zero?
Yeah, that's why it's got hidden
Oh,
zero.
that's because
Yeah.
yeah. Okay, cool. So what I did with this one was I slid the refraction slider up until the boat had 0 hidden height.
Okay.
Okay, and that would have so to have 0 hidden height on the boat, which we see in the observation, you would have to have a refraction coefficient of 0.81. I mean, even if we put in zero, even if we put in,
I'm
right,
not seeing 0.
Okay, we can see the whitewash from the
Yeah.
boat. Yeah, we can see the whitewash from the boat at the
Sure.
bottom very clearly. What do you mean? There's nothing obstructed, right? It would be obstructed behind the horizon. The horizon should be at 4.6 miles. Okay, we don't see a horizon in front of the ship that's blocking anything because we see the whitewash from the ship.
Oh,
And
what
also,
was the horizon?
The horizon should be 4.6 miles, the geometric horizon.
So what would be the hidden height, assuming
22 foot, assuming no refraction, with standard refraction, which shouldn't be possible in this case because we have what would cause upward refraction. So obviously we're not going to have 16%. We're not going to have that downward refraction. But so even with standard refraction, it would still be the bottom of the ship would still be hidden by a certain amount, and the geometric horizon wouldn't be much further away. Okay, it would be 16%, 14% further away.
How high was the observer? The camera?
15 foot.
And the boat.
Yeah, with standard refraction at 16 feet hidden. How high up on the boat does the whitewash go?
It doesn't look very high in the observation. I don't know, have another look at it again. I mean, it's probably not something you would be able to measure exactly.
Yeah, like, do you have a picture of the boat from fairly close that you can like compare the two?
Yeah, I think so. Again.
So what we could do is, if we know the boat and how tall it is, we know how many degrees per pixel in the vertical, and so we actually could tell how high that whitewash actually is appearing.
Right. So this is a horizon test as well, by the way. This is a geometric horizon test. Okay, so you would have to say that, like, where are you seeing the horizon? You're not seeing the horizon in front of the boat because you're seeing the whitewash. The amount of refraction you have to have a horizon at 10 miles, okay, that would be 0.81 refractive index. We don't have the meteorological conditions present to have that.
Well, you have a very limited snapshot of the meteorological conditions. Just to be clear, to be fair, you have one point of temperature above the surface.
Yeah, but it's in between
and you
point
don't
A
know
and point
the
B.
elevation.
Well, it's in between.
But you don't know. You don't have a vertical temperature reading. So you don't know, is it colder another foot up? Is it warmer another foot up? You don't know that. You don't know even the height of the air temperature reading. So you don't know the meteorological conditions, so you can't say definitively that there is zero refraction happening.
Okay, well, what we do know is that we have
Right?
warmer water than the air temperature. Okay, that would cause upward refraction. Okay, this is better than
Heat above the surface.
any observation from any globe earther that I've ever seen. We literally have a buoy that's giving a reading right at the time of the observation between point A and point B. It's not bad. Like this is a decent quality observation. Also, we're using infrared as well. Right?
I
It's
don't
not
care.
just
Infrared
an
is nice because infrared is nice because it's a limited wavelength. And it reduces chromatic aberration, which is really bad in the Nikon cameras. But it's not magic. Infrared isn't refracting less in any
No.
quantitative amount that's going to matter.
No, I get it. I just remember you were saying earlier that you had almost perfect conditions in your sunset observation because you had 1 degree difference between the water and the air temperature. I mean, you're doing that over a huge distance as well, where you could have a lot of fluctuations in the water temperature and the air temperature between point A and B. Okay, so this is much closer. It's only 10 miles. So, I mean, we're not seeing any sign of that geometric horizon. Okay, we don't see any miraging effects or anything like that.
Well, we do see a horizon, which is impossible on flat Earth. Number one.
Oh, that's the most ridiculous thing I've
You
ever
can't
heard.
have a crisp horizon on flat Earth. It's
You're trying to-
100% impossible to have a crisp horizon on flat Earth.
Horizons aren't very crisp. If
You're talking about the horizon.
If you zoom right in on a horizon,
This horizon is crisp.
At all. Yeah, it's called a vanishing line.
But the one you're showing me is crisp.
Point.
You can actually, there's no such thing as there's no such thing as a vanishing line in reality. That's just an art class technique. But
No,
you can
there
see
is
the
such a
actual in
thing.
your
Oh,
picture.
so
you can see the waves.
You want to deny perspective.
You
deny
can see
that we
the
have a
individual
vanishing
peaks
point.
of the wave. No.
Yeah.
Yeah,
You can't have a horizon
vanishing
on flat
point
Earth. That's the most ridiculous thing.
an art. That's right. It would be blurry.
It is blurry. When you zoom right
there
in
would
on
be
a horizon,
nothing
it's
stopping
blurry.
the light from the 1,000 mile away, other than the blur of the air.
Well, you're kind of getting a little bit off track
So
right
you
now.
would never have a crisp.
You meant to be talking about this
No, but
specific
you
observation and
said
the
this
distance
is
of the horizon.
No.
So now you've
You
changed
said,
the topic. You've
quote,
changed the topic from whether you can have a horizon on a flat Earth or not. See, now you were just saying you were just look. I'll mute you, dude.
Quoting you. Dickhead, quoting you.
Okay.
Quoting you, dickhead.
Calm down.
Quote, this is a horizon test. Unquote.
I'm going
words,
to mute you
dickhead.
Don't.
Okay,
I mean, you
I
can mute
have
pretty
a
much
question.
everyone, but not make me streaming.
Did you?
Hold on a second. Just for a second, right? I'm gonna unmute you in a second, dude. Don't start screaming, dickhead. You just stopped someone having mod powers on your server because you told him that you're supposed to be nice to people. I've been nothing but nice and respectful since I came in here, and now you're just screaming and calling me a dickhead. You're making yourself
Go back
look terrible.
to the part where you said you're over talking me, and you are the one that brought up the topic.
Me.
This is a horizon test.
A geometric horizon test.
Did you not say this is a horizon test?
Yeah, for the
Okay, I have a question.
Geometric horizon test.
Got it.
Yep.
So we're talking about that. So we're looking at the crisp horizon, something that doesn't work for flat Earth.
It's nowhere to. This is a globe test. Don't worry about flat Earth.
So you falsified flat Earth in this observation.
How so? You're coping
the
hard
flat Earth
right now,
fails
dude.
this.
At least I made you
the crisp horizon.
I made you lose your shit by being calm and just showing you an observation. You started screaming out.
No, you were an asshole over talking me.
No,
you were an asshole over talking me.
Dude, so you start screaming, dickhead, over and over again.
You brought up the topic of the horizon, and now,
Thanks for the clip, by the way.
You didn't look at everything either.
You made
on
yourself
the left,
look like a fool in this.
To the left,
Yeah, what
To the
about it?
left of the boat, there's a buoy that's obstructed by the horizon. Uh-oh, that's not possible in flat Earth.
Yes, it is. Have you not heard of sinking refraction?
No, it's not.
Have you not heard of sinking?
Oh, now
All right,
there's refraction.
I've never said there
Oh,
wasn't
now there's
refraction.
refraction. Oh,
Yeah,
got
so
it. Now there is refraction.
you
First there was no refraction, and now there is refraction.
no, I
How
said you don't have
convenient
the
for you.
This is what I said, right? So I said you don't have the conditions present to have the extreme refraction that would be required for this observation to work on a globe. I don't deny refraction. It's my favorite topic to talk about, actually. We could talk about refraction for hours if you like.
But
But how come you can't be nice and just have a normal
whatever it
conversation?
needs to do,
Why you gotta
whatever
be
refraction
toxic?
needs to do, it does it for you.
No, I'm not saying that at all. I'm just saying here's an observation. I'm just
Oh, you
presenting
are.
the
100%. That's what you're saying.
No. See, when you
100%.
get cornered, you turn toxic.
No, you've falsified flat Earth is what you've done here.
How did I falsify
Because you
flat
can't
Earth?
have a crisp horizon, and you can't have that. You can't. I just said it, and you can't have a buoy blocked.
Yes, you can.
I don't know why you can't have a crisp horizon on flat Earth.
Yeah, you absolutely can. And you can have
Because there's
sinking.
nothing between you and the
Well, so
distance horizon, so you're just going to get the blur
can I
that
explain
is
this one?
due to the atmosphere going. Yeah, go ahead.
So the horizon is the eye level with you. It's the center of your spherical vision. The hemisphere is above. You guys turned it into you guys took that hemisphere, the sky hemisphere, and you duplicated it, you mirrored it onto the ground, but beneath you. But either way, so it's a sphere. You see in a sphere. The horizon is a center point. So no matter what world you live in, that center point is gonna have a limit to it because the sphere is spherical. It's not a Euclidean infinite vision God mode. So because you're standing on the ground, because the ground is basically very close to that eye level horizon center of your vision. It being close to the horizon is going to cause things to disappear bottom up because the angle from the things farther than your limit are basically converging into. Yeah, I think converging would be the right direction. Converging, maybe. Either way, it's basically intersecting with that limit of where you can see, and optically you're getting basically a cutoff close on the bottom because the ground is already basically at the center of your vision. Therefore, the things that you can see below it are less than the things you can see above the ground because there's nothing in the air to really cut off things. So that's why when you go higher in the air, you can see farther.
I would also
Okay,
like
I
to
have a
add, if you go on
question.
Google Earth, where the canopy is where he's at, I put it in chat. It says 9 meters,
The Earth is
so
definitely
a
not
little bit
flat.
more than 15 feet. Just like last
Clearly,
week. Remember that?
yeah. Clearly,
Yeah.
it's not 9 meters. And last week,
remember
okay, yeah. So I looked that up. So in the forget the exact name of the channel, BLSM 69, whatever it is. Okay, that was
Okay,
done in
okay. I have
2019.
an
Okay, and
example.
it said 8 foot
You
on
can
his
elaborate this.
Google Earth screenshot. Okay, now they change the data sets sometimes. Okay, and in coastal areas, it can change by a couple of meters. It's not uncommon for that to happen. So it showed 2.3 meters higher in
Saitama,
2026.
do you have a question,
right? So if they change
Saitama?
up the data set,
Yes, yes. Go.
How do you know that?
because I looked
Give
it
me one
up.
second, let me
It's
mute the
common
bot.
for that to happen.
When you said if the earth was flat, what do you mean by that?
Now, if the Earth were flat, the entire ship would be visible at once, right?
You're gonna try, okay. When you say if the earth is flat, what does that mean, flat? What is that? What does that look like in your mind?
I just want to say that if the Earth is like flat, you can directly see the ship from your then I just want to see again I am asking the question: when you stand on the shore and watch a ship approaching, you first see its masts. Then gradually the entire ship becomes visible, right?
So you're talking about you're standing on the shore and you see a boat going across the water, and eventually you don't see it anymore.
Now you first see its masts, and then gradually the entire ship becomes visible. When the ship approaches, it becomes visible.
Okay, so it's yeah, the ship is coming towards you at the shore, and you don't see it, and then it's coming towards you, and then you see it.
Yes, yes. But
Okay, so just like on a room, if there's a book, right, or on a place, if there's a book with letters, right, and it's far away from you, 10 miles, you don't see the book, right? You don't see the letters, you cannot read it. But then when it gets closer to you, eventually you see the book, and eventually you see the letters, right?
so I might not. Uh,
Is that correct, or did I say anything wrong?
Let me clarify this. Actually, I just wrote this question on my book, so I just read it directly from this book. Again, I am saying that when you stand on the shore, right, and watch a ship is approaching towards you, you first see its mast, yes, and then gradually the entire ship becomes visible to you.
It
So,
doesn't have
if
a
the
mast.
earth it's like what is let's say
So it's first you see a blurry thing across the water, and then the image gets clearer and clearer and clearer, and then you see the whole boat.
yes.
Yeah, that has nothing to do with the curvature of the Earth. That can happen on a horizontal, that can happen on a flat surface. That's the conditions of the air, the particles in the water, humidity, how hot the day is. It's gonna cause blockage of the view. So depending on the conditions and all the variables, you're gonna be able to see things at a certain distance or not see them.
Yeah.
Yeah,
Okay.
and also things with a distance, they kind of like for your angle of the view of your eye, they get smaller and smaller and smaller, right? Because when they get further away, and when you add that to the conditions in the air and all the humidity, water particles, dust, temperature changes between you, your eye, and the object that you're looking at, there's going to be a bunch of things that are going to cause you not to see it. Cause your eye to not be able to see that image. Because the angle of your eye and all the other conditions across the point of view, it's not allowing you to see that object. Yes, no, maybe. Are you still here? Do you leave? Yeah. Oh, Saitama. Yeah, you're still here.
Yeah, I'm hearing. I'm giving my question in chat box. Uh,
So listen, you're arguing that you don't see the boat because it's behind the curvature, and then when it
no,
comes
I'm not
closer to you,
talking about boats. Mainly, I'm talking about ships. I just
no, nobody's
ship
talking about
the ship.
books. I mentioned books as an example. I'm saying
Oh,
the
okay,
ship.
okay.
You're arguing that first you didn't see it because it was behind the curvature, and now it's getting closer to you, above the curvature, and now you can see it. Is that what you're arguing?
I I have given my question in the chat box. If you can,
Well, let me know when you want to talk then. So listen, all the variables to not be able to see the boat across the shore, across the water, is not because of the curvature. It's because of many other variables. The angle of your eye or the optics that you're using, the air that is not transparent completely is gonna block your view eventually. There's darkness at the other side. There might be a storm 20 miles from you. You're not gonna see stuff inside the storm, are you?
no.
Exactly. So there's many other variables that you can put together and that will block your view of the object and has nothing to do with the Earth curving.
It's great thinking. I think my confusion is clear.
If it's a perfectly clear day, still the angle of your eyes is gonna have a limitation. You know, you don't see forever, right? And things get smaller and more smaller with that angle. So even if you have like clear conditions, you still don't have the angle to see everything. You cannot resolve the image. You cannot see every detail of something far away. It's gonna be, for a lack of a better word, pixelated. The details of whatever is further from you is gonna have less details that you can see, less details until you cannot see it anymore.
Okay. Then why there is earthquakes happen in the world?
Why? I
Earthquakes
guess, well, that's a phenomena that happens. Why does that happen? I mean, you can have earthquakes on many
if the flat
surfaces.
is sorry. If the earth is flat, then why earthquakes happen?
Yes.
Then
Why
there's no
earthquakes
need
happen?
for
Because the earth
yeah.
shakes and the earth is not curving, so the earthquake is happening on a non-curving earth.
I think if the earth is flat, there is no need any movement of plates because the if the earth
Plates,
is
plates,
round, then
plates,
the
plates might be flat. I mean, many plates. I think plates are flat, no? Unless you have a bowl. I mean, if you have a plate, the plate might be most likely horizontal, isn't it?
maybe
You don't have plates that are balls, right? Plates are not spheres, are they? Sphere plates don't work. That's why when you go to the store, plates are flat. So if you're talking about Earth having plates, I mean, welcome. Not a globe. Plates don't work on a globe.
oh
If that is your argument about plates, that I mean, this is speculation because the cause of the earthquakes. I mean, there might be many reasons below the ground that are causing earthquakes. Maybe a volcano exploded and your house is
yes,
shaking, right? Maybe there's construction, like people like constructing under the ground, and you feel your house trembling, right? There might be an explosion or whatever. Yeah, water under your house flowing, earthquakes. Yeah, can. And then the big ones, like you're
yes.
saying, plates moving. But if plates are moving, I mean, that doesn't prove a globe, though. basically the globe proof will be like measuring the earth and the water across the earth, curving, right? Curving to the specific rate that the globe claims. The globe claims that is a certain size, right? This big, it has a radius, a circumference, specific dimensions. So when we go to the physical and natural world and we check the world and those dimensions on paper are not on the surface of the earth, then the earth is not that thing that you read about. You know, the image of the globe that you see on the books or the TV. The earth is not those things because the earth is not doing what you saw in the book or what you read. You know, the earth is a globe, you read it somewhere, but the earth is not doing that. Do you get what I'm saying?
Yeah,
Yeah, when you
but
go to
why
the
is that?
earth,
Why
you,
is
you close the book. So you first you learn it. You in the book you saw an image, and the image was labeled globe Earth, and it says the globe Earth curves to a specific ratio, and you learned that information, right? And now that's you hold a belief because you haven't verified, but then you say, okay, this that I just learned or this information that I gather about the globe Earth, and now I'm gonna close the book and I'm gonna go test the Earth to see if the claims on the book are true. So now you gather more information because you go to the Earth, right? And you measure it and you come to new information that the Earth is not curving. So it cannot be the thing on the book. Because the thing in the book claims that it's curving.
yes,
Yeah, it's pretty simple though.
but there are many questions like if the Earth is flat there, then there might be some the ending point of this Earth. If
Well,
we
there
go,
might be. Think about it. That from the book to the Earth testing and checking, right? We can do those things. We can actually repeat that. I can do it. You can do it, right? Our neighbor can do it. My friend can do it. Your friends could do it, right? That's stuff that we can do. Now, the ends of the world, the edge of the world. Can I go there? Can you go there? Yes, no?
uh,
Can you? Can I?
no,
Exactly. So that will be speculation, something that we cannot verify. It will be an unknown, something that I cannot tell you it is there, but I cannot deny that it is there. I cannot tell you yes or no. I can tell you I don't know because I haven't seen it. I haven't been there,
but
right?
but the organizations like NASA and like them, they can ensure these things by searching for satellite or rockets or then, some greater experiments.
Formulate that question
Uh,
again. Can you say what are you saying about NASA again?
uh, big companies like NASA and many other companies, they can search for this Earth ending with satellite or much more advanced.
Yeah, companies can make satellites. Company can make technology. Yes, companies can do that. Nobody's denying that. Yes, you're correct. Companies can make technology. Yes. What's the issue with that?
They can search. If we individual can't search the Earth ending, they can. They have that great technologies
They can what?
to
They can
build.
what? What are you saying?
Uh, NASA can. I have heard that NASA can build so much highly technologically things, and they
When we use the
will
technology, when we
like
use technology and we check the Earth, the technology shows what we already know. What your senses are telling you that the Earth is not curving, is not spinning. So the testing, the technology that you're talking about will disprove the globe on the book. Falsify it. Because when we use lasers and we use technology, we use optics, we use communication systems. All of that stuff requires that it doesn't work on a globe. Any of that stuff. We use
Nice.
aviation.
That's interesting topic.
Stuff like aviation requires a flat, motionless Earth. So stuff that we use in reality, we practically use in the physical, natural world, doesn't work on a globe.
It's like
So what you gonna know?
RNA.
It's not about what you know. Hello.
Hello, hi.
What you gonna know?
What you gonna know? What do you mean by that? Can you formulate your question cohesively?
Do you have a question about the flat Earth?
You have a question?
Yeah, I have two questions.
Okay, go ahead. What's the question?
The first question I'm asking about how does the Antarctica's people cannot see the sun for 6 months?
Don't move above the flat Earth, and it moves in certain patterns like clockwork that repeat in cycles like a clock that requires a clockmaker, a watchmaker.
Yeah, I can imagine it, but it can be correct if the sun cannot be seen.
Are you saying that over a flat surface you cannot have lights going in circles? Is that what you're arguing for?
Yeah. I'm asking about that. Yeah. So what do you think about it?
So you're saying that lights, you cannot have lights going above above a flat surface in circles.
Yeah, light from the sun. We cannot see it for 6 months. After 6 months,
Think
the
about
sun
this.
can
Okay.
appear.
Think about this logically. Okay.
Yeah.
The Earth that you're standing on, the Earth, the thing that in question, right? The thing in question, you can check that, and you can verify that it's not curving, right? And then Antarctica, being one of the flattest regions of the world, because Antarctica is made out of a bunch of ice plateaus. You know what a plateau is? A mesa, a table, a bunch of tables. Antarctica being one of the flattest places in the world, when you go and visit that region of the world and you look up away from the flat Earth, away from it, right? Up, you look into the sun, up, not to the Earth, then you see the phenomena that we call the sun doing what it does above the flat surface that you're standing on. You get that?
No. Can you repeat it?
What?
Can you repeat what you just say?
Yeah, I got you. The sky has nothing to do with the ground. If you want to identify if the Earth is flat, you measure the ground. You don't look at the sky, because whatever is happening in the sky is happening over a flat surface. Or if you measure curvature and the Earth is curved, then whatever is happening in the sky is happening over a curved surface. Simple.
So the next question, I'm asking about how does some people see a certain stars in the sky, okay, when he looking above the Earth. So in the upside of the Earth, the people cannot see the same suns.
You said the upside because you're pre-assuming that you are under a ball, but But you gotta say on one region of the world you see certain lights, and then on the other region you see other lights. But that does you're already pre-assuming that you're standing on a globe. That's why you're thinking that you are standing on a globe. So this is a pre-assumption, presupposition.
Right,
You haven't
and
verified.
they do see some of the same stars. They don't see some of the same stars. It's not like they have a totally, absolutely unique sky. They share some stars together.
Also, second question's answer is the same as the first. The sky has nothing to do with the shape of the ground. Whatever's happening in the sky is happening over a flat surface if the Earth is flat. At what point are you going to go outside and measure and identify if the Earth is curving or not?
Yeah, exactly. Let's just clarify that we understand that we're given a reason why we see stars do what they do, why we see the sun do what it does, same as the moon and the planets. We understand that we're all given the reason why we have seasons, right, and eclipses and all these different types of astronomical phenomenon, right? And that reason is that the Earth is a rotating sphere, right? Now, for that to be true, the surface must be curving. This is what these guys are getting at. So if the surface is not curving, then those reasons that you're given for the astronomical phenomena are false.
فهمتش انت ولا لا؟
Sorry about that. I didn't mean to scare him away.
He scared himself away. He was thinking too hard. And then he was embarrassed. Big embarrassed.
So I think I have another question.
What's your next question? Go ahead.
What about the day length and seasonal changes around the world? Like,
The sun moves from its position in cycles, right? It moves in cycles, and those cycles repeat year by year, day by day, week by week, month by month, year by year. And those cycles, when depending on the sun position above the sky and the region of the world that you're at, it's gonna affect, the seasons, the temperature. But that's the sun moving in cycles up in the sky. And it's light shining on the ground. It's causing weather phenomena.
then sunrise and sunset would occur at the same time all over the world. Is that right? Which is not in that case in reality.
If you have a light in a room in your kitchen, it's not gonna be the room in your neighbor's kitchen. I don't know. You're trying to say that if the Earth was flat, therefore it should be daytime everywhere in the world or whatever. That's what you're trying to say. That is, you're imagining. You're imagining something in your head, and you're trying to say that thing that you're imagining in your head doesn't work. But that's not what we're talking about. That's you making that up. That's not the Earth that we're standing on. The thing that you're imagining and you labeling it flat Earth, that's not the Earth that we're standing on. That's just an imaginary thing that you're thinking about that doesn't work in your head, and you're trying to say, hey, it doesn't work in my head, therefore what you guys are talking about is wrong. That's false logic. You're committing logical fallacies that you are attributing those things to us. You get it? Yeah, because when you say flat Earth, you don't even know what that means. And you're trying to say, even though I don't know what that means, it doesn't work, therefore you guys are wrong. And the Earth is wrong. But that's false logic.
No. From finding
Check your mic, check your
many.
mic. Your mic is breaking up. Double check your mic. Fix your mic. Before you ask anything else, comment. Am I still here, or the other guy? think I'm gonna unmute the bot. Is it still going, the bot? I muted him for the other guys.
And
Alright, there I posted the other one there. That was from Karma. Put a little more love into it. Find that fucking hilarious, man. Loblin. God damn. I think Logi's is a little bit more, how do you put it? High res, you know, for thumbnails and shit. And then the other one's perfect for like a meme or whatever. I don't know. Work in progress, but you spawned the idea, so good luck putting that back in the bottle.
I could put on my conversation with Ruhif if you want to listen to that one. A good one to listen to also is Lanolin versus McToon a few weeks ago. Except the only problem was all of the anti-flat earthers were trolling the soundboard. Every time Lanolin would talk, they would just play sounds constantly, and there was no moderation. But Lanolin destroyed McToon.
Hey, Indio. Before you started, DJ, just a quick question.
Yeah.
You there, Indio?
Yeah, I'm here. I'm salvaging my honor, dude. Hold on.
Okay.
No one's gonna say I got the frickin' height wrong. I was dead on the motherfucking money. Okay, DJ.
Go ahead, DJ.
So that's from the U.S. Geographical Survey called Topo View. There's the pin about where I was, 15 feet.
Oh, awesome! All right, I want this for my my video, so I'm just gonna.
I'll give the link for the Topo. Yeah, I'll give the link too. So
awesome, perfect. And I'm gonna clip you saying that as well.
unlike McToon, I have honor to defend. That dude has no honor.
It says exactly 15 feet as well. That's excellent.
I knew I'd use the Geological Survey or something. I knew, like, I wouldn't use Google Maps because Google Maps is too fucked up. And they say, Google says that their vertical data is the worst. They said it could be off by as much as 30 meters. Now, they said this years ago, but I'm just going by that because they don't make any assurances to the accuracy of their product. You know, they try to make it accurate because if it was wildly inaccurate, then people wouldn't use it. But they want to make it good enough so that people don't whine. So
can I use this site to find the elevation for different places?